Okay, this is Ms. Crockett, and I'm going to do a video that encompasses position time graphs, velocity time graphs, and acceleration time graphs. In all three cases, time is on the x-axis, and on a position time graph, you will either see an x or a y on the y-axis. The x denotes horizontal position, whereas the y would be a vertical position. We begin physics just talking about horizontal positions. On a velocity time graph, you simply have velocity on the y-axis, time on the x, and then an acceleration is acceleration on the y and time on the x. Okay, let's just start out with an example here. Let's say 0 represents the town square, and we have Bunny Barrett starting at the town square, and he hops to the north at a constant velocity. So that would be represented by line A. Okay, assuming this is a nice straight line, line A would represent Bunny Barrett hopping at a constant velocity toward the north. The slope of a position time graph is equal to the change in the y-axis, which in this case is change in horizontal position, divided by the change in the x-axis, which is change in time. That also happens to be the equation for average velocity. So we can say that the slope of the line on a position time graph is equal to the average velocity. So if we take a look at the slope of line A has a constant positive slope. So therefore it has a constant positive velocity. So if we move this information about Barrett to the velocity time graph, the line would look like this. It would be a constant velocity, so that means it doesn't increase or decrease, and it's a positive velocity. A positive velocity would be something like hopping north, which is my example here, hopping east, going right, going up. Those are positive directions. Okay, the slope on a velocity time graph is equal to the change in velocity divided by the change in time, which is also the equation for average acceleration. So on a velocity time graph, we can say that the slope of a line here represents the acceleration. So if I look at line A, the slope is 0. So if it has 0 slope, then it has 0 acceleration. Remember, acceleration is when you're speeding up or slowing down. And if you're moving at a constant velocity, like if you're on a highway with a cruise control set, then you're not speeding up and you're not slowing down, so your acceleration is 0. You can still be moving even if your acceleration is 0. You're just not changing your speed. So line A moved to an acceleration time graph would be down on the 0. It has 0 acceleration. Okay, if Barrett decides to hop from the town square to the south, the line would look something like this if he hopped at a constant velocity. Now, if a line goes up and to the right, that's considered a positive slope. If it goes down to the right, then it's considered a negative slope. Okay, so for B, Barrett has a constant negative slope, and a constant negative slope equates to a constant negative velocity. So a negative velocity just simply means that you're moving at a certain speed in the negative direction. So if we want to move this to the velocity time graph for B, it needs to be a constant speed. So the line's going to go horizontal. It's not speeding up, it's not slowing down, but he's traveling south, so that's considered a negative velocity. I just put some arbitrary numbers here. So maybe he's headed 3 meters per second toward the south, so it would be a negative 3 meters per second the entire time he's moving. So his speed does not go up or down, it stays constant. So just like A, if you have 0 slope on the velocity time graph, you have 0 acceleration. So line B on the acceleration time graph would look like this. Okay, moving on to line C. Line C, he starts out hopping slowly, but as time goes by, he speeds up. I know this because I'm looking at the steepness of the slope. The steeper the slope, the faster Barrett's moving. Okay? So if slope indicates speed, the higher the slope, the steeper the slope, the faster you're going. Barrett starts out with a very shallow slope, followed by a steep slope. So the slope is increasing, and it's a positive slope. It goes up to the right. So for line C, he has an increasing positive slope. Therefore, he has an increasing positive velocity. If I move that to the velocity time graph, I would start out with something very low. Maybe he started at 0. And his velocity increased as time went by. So line C would represent an object moving with a constant acceleration. The object is speeding up as time goes by. Okay, if we look at the slope of line C, it's a constant slope and it's a positive slope. So line C, we could say, has a constant positive slope, therefore a constant positive, and then just insert acceleration, because that is what the slope represents on a velocity time graph. So if we have a constant positive acceleration, this would represent a constant positive acceleration. It doesn't increase, it doesn't decrease, it stays the same. The velocity increases, but the acceleration is constant. That means the velocity is constantly increasing at the same rate each second. Okay, moving on to D. Line D has a very steep slope to start out with, but it's followed by a shallow slope. So that's a decreasing slope. And it's still a positive slope because it goes up to the right, so it's a decreasing positive slope, therefore a decreasing positive velocity. If I move this to the velocity time graph, I've got to start high, but the velocity is decreasing, so I will go down with my line. I'll have a negative slope. So D would look like this. I would start out with a big velocity, and as time goes by, velocity would get less and less. Slope-wise here, I've got a constant negative slope, therefore a constant negative acceleration. So this right here could be represented by line D here. Okay, moving on to E and F, last two. You can see E and F are both negative slopes. They go to the right and down. This E starts out with a shallow slope, but it ends up with a steep slope. So it's an increasing slope, but it's negative. So it's an increasing negative slope. Therefore, I have an increasing negative velocity. So for E, I start out with a small velocity. Barrett's headed south, so it's going to get larger and larger as time goes by, but it's got to go in the negative direction because he's headed south. So this would represent a bunny that is speeding up while moving south. Okay? Speeding up while moving south. Slope here is a constant negative slope. So that means a constant negative acceleration. Okay, and then F is very fast, followed by shallow. Very fast, followed by shallow. So very steep, followed by shallow slope. So that's a decreasing slope. And it's a negative slope. So a decreasing negative slope gives me a decreasing negative velocity. Starts out fast, so I start out with a high number, but he's slowing down. So he's traveling south, but he's slowing down. That could be like somebody driving south, but coming up to a stoplight. So they're slowing down while traveling south. Constant positive acceleration, or constant positive slope, represents constant positive acceleration. So the line for F would be up here. Okay, I'm going to stop this video. I do want you to watch the video on how to know if acceleration is positive or negative.